Welcome, welcome, welcome. Let some people get in. Good, looks like everybody's kind of coming in. Again, we're just wait a few minutes to give everybody a chance to come in. Again, some things on the screen there that you hopefully should be able to see just about lectures and stuff in general. You should also have a chat box that you can see. You just want to type and make sure everybody can hear me okay. Just somebody want to type yeah or whatever. That'd be great. How you doing? So again, since it's the first time, we'll give everybody a few more minutes to kind of come in, and then we'll kind of talk about everything. At this moment, when you do come in, your mic's going to be muted so we don't all kind of talk over each other. So at the moment, if you need to ask a question, try to use the chat box. Perfect, good, good. I'm glad you can hear me. Also, again, if you need to use chat box, you can do that. I think there's somewhere where you could kind of raise your hand if you want or ask something. How's everybody doing? Good to sort of virtually see everybody here. So again, as you can see on the screen, and as I kind of talked about, all these will be recorded, and they will eventually make their way up probably onto Canvas, and we'll talk about all that kind of stuff as well. So obviously remember, be respectful to everybody, any type of comments that you make and all that good stuff. And if you do want to use your mic, I can sort of unmute you, and you can use your mic if you want. Or again, you could just type on the chat, say hello to everybody virtually. You know, it's good stuff. So again, we'll kind of get into everything in just a couple more minutes. Kind of again, give everybody a chance to do that. I'm hoping most of you were able to find the link on Canvas. Yeah, so at this point, we're you can do the audio. I'll probably keep your video off. Yeah, I'll be honest with you. I see all kinds of boxes on my screen, and before I know it, I got 30 boxes on my screen. I can't see anything. So you could keep your mics off as well. Probably. I think you all muted. That way, again, we don't accidentally hear anything that we don't want to hear. Right? Keep that in mind, just in case your mic comes unmuted. But I think right now they're all pretty much going to be muted again, so we don't talk over each other. We don't hear things that we don't want to hear, perhaps. And also with the camera as well, we don't see things we don't maybe want to see either, you know. So I think everybody's found the chat. I think that's probably a good way to do that, to sort of ask questions and stuff like that. Because again, I can see the chat and all that good stuff, so I can I just read your question out loud. Also on the chat, if you want to ask something more privately, one-on-one, you can just send it to somebody just straight, or to me just straight, sort of privately, and if it's sort of labeled like that, I'll try to remember not to read it out loud and just obviously type back to you and stuff like that. So just out of curiosity, I think you also in your participants window have like a yes or no type of button, I think. Just curious, you guys went through the link on the Canva Zoom section, or the one on the module section? Which link did you guys go through to get on? We'll start with, did you go through the modules link? Hit the yes or no. Yes. Okay. No. Okay. And then did most of you go through the Converse Zoom section? Okay. Yeah. So a question was, you can, in terms of asking questions, you could type it in the chat if you like, or if you want, you could raise your hand. I think there's a little button to kind of virtually raise your hand there, and I'll see your hand go up just like you did right there. And I can unmute you if you want me to unmute you. You can use your microphone. And again, a reminder that that will be recorded on the video that will be posted, or if you rather, you can just type it on the bottom. Either way you pence. That's usually where you can find like the yes or no sort of check mark type thing, and the raise your hand. And again, in the chat, you could do it. So I got those windows up on my screen, taking up some of my screen and stuff like that. So again, I would probably keep your video off as well for what we talked about earlier, but also so I don't have 40,000 little things on my kind of screen while I'm trying to look at things. You hopefully should be obviously seeing what's on my screen right now, this sort of welcome to online and sort of the rules that are happening there. So you should be able to see what I see. At some point, I may not share my screen, and then I think you'll go back to just the regular Zoom sort of white screen that you entered on. So I think you'll be able to kind of see that. Yeah, if you have something like that, you can. If you want to point, I think you probably have access to some pointers, like if you're talking about something. But first, maybe just try the chat what your question is, and I probably be able to figure it out. Again, that way you don't have so many people like writing all over the screen and all that good stuff as well. All right, so well, let's just get a little started here, and then again, we can talk about a bunch of stuff today. Maybe we'll do a little bit of lecturing just so you can kind of see how it's going to be. And we'll talk about sort of how everything's going to sort of go on from this point forward. So first off, like I said, up on the screen, you can see some things. Again, all these online lectures, and again, if we, which I anticipate we'll probably do as well, open up for lab during at least the beginning part of lab on certain days. So if you still do have questions on sort of the lab part, I'll be there to answer your questions and stuff like that, like if we were in class together. Again, all these will hopefully be recorded, technology working correctly, but they all should be recorded. So again, if you participate with your voice or video or any of those type of things, obviously you'll be part of that. If you don't want to participate in that sense, asking questions or something like that, you obviously can still listen to it live. You won't be really part of the recording. You could, even if you want, type in the chat box. The chat will not be part of the recordings, I don't believe. So you can chat something, still get your question asked, and again, you won't really become part of the recording, if you will, or anything like that. So as we talked about before, again, remember to always think about what you're typing in those chat things. We still want to be respectful to everybody with our comments and stuff that we make. My goal is after these sort of live lectures, they will be posted up on Canvas. So again, if you want to kind of watch them again, go through them again, you should be able to watch it like a video, and you'll be able to again see pretty much everything that you see on the screen, on my screen that I screen share with you, which most of the time will be probably our PowerPoints and stuff like that. Obviously during lab time, it may just be, some talking and not very much sort of visual, unless somebody asks a question or needs help on something, then you might be able to obviously see that, but you'll be able to see everything and listen to everything. It does take a little bit of time to sort of process these videos sometimes. So my goal is to hopefully get it up there, perhaps at least the latest the next day. With that being said, my thought process in terms of lecturing and sort of labs and all that kind of stuff in terms of meeting is that we would probably continue to meet, at least do these live lectures and again labs at their normally scheduled time. Again, that's usually when most people are still available, I would assume. Obviously a lot is changing, so everybody has some different things that they may have to take care of during different times. So I would encourage you to try to obviously attend the lectures live. So again, if you do have questions on anything, you could ask. And if you by some chance can't obviously attend live, like I said, hopefully within the next day, it will be back up online for you to take a look at and actually listen to and stuff like that. Any questions on sort of that there? So as we've talked about, everything is again going 100% online. So everything is going to be done online for the near future, it seems like, until perhaps we're allowed to back together. But as things are looking, I'm not really sure that's actually going to take place. So that includes both the lecture portion and also the lab portion. And so both things will be done pretty much online. So like I said, in terms of the lecture portion, every Tuesday and Thursday at 5:30, we'll have a meeting scheduled. And again, we'll go through lecture as normal as we normally can. In terms of the labs, we have a lot of study assignments coming through in the next couple of weeks, I think. So my thought process on lab, again, is at kind of the normal time after lecture. Again, I'll open up a meeting, a lab meeting for any type of questions, at least at the beginning and stuff like that. So you could drop into the meeting if you want, or come to the meeting. And if you have questions on calculations or something like that that involves either a study assignment or an actual lab that you're doing, then I'll be able to answer that. In terms of the lecture and the lab part, I will be doing probably different meetings. So one for the lecture and one for the lab. And the reason for that is that way we'll have sort of separate recordings that I could post up online, one being the lecture sort of video and one being the lab video. So we could kind of keep those things separate. Any questions sort of on that part? And again, if you're just coming in, you can use the chat box there to ask questions if you have questions or anything like that. Yeah, so this is the next thing that I was going to talk about, is actually how the lab portion is going to work for those experiments that are truly sort of hands-on experiments. So as it stands now, and I believe it will continue, you will be sort of required to go and watch a lab video, I think on YouTube, that Professor Water has prepared of him sort of performing the experiments. So for example, this week we were supposed to do experiment number 8. sorry, number 7, I believe, experiment 7. And he did make a video, sort of a quick video that he could before he sort of got kicked off of campus too, I think. But he made a video of him doing the experiment. And I will put sort of a detailed announcement up on Canvas of what you really need to do. But essentially what you're going to have to do, for example, for experiment 7, we are going to only do part 1 of experiment 7, which I believe was the silver chloride part. And what you'll have to do is you'll have to go and watch his video. And during his video, he will sort of show you the stuff. He'll show you sort of the step-by-step of performing the experiment. And what you'll need to do is, since it's technically a formal experiment, you'll need to take your lab notebook as you watch it, and you'll need to write down the procedure that he's doing and also document, obviously, the numbers that he gives you. So he'll give you the numbers, like he'll weigh out the empty evaporating dish, and he'll give you that number. He'll weigh it out with the solid in it and so forth. So you need to sort of write down everything in your lab notebook for this one, since it's in a formal lab, just like you were doing it yourself or working with somebody like we would do in class. You need to have in your notebook your procedures. You need to have, obviously, like the data table. And then obviously you need to fill in the data table as he does the experiment. The good news is I think I saw the link, so it's only like a 3-minute video. So it's not like an hour-long video or anything like that that you need to watch. So you're going to watch the video. You're going to fill it in your lab notebook just like normal. You then will proceed to pretty much do the lab report. Again, just part 1 for experiment 7 in this case. And since this is a formal lab, you will have to type up the lab report. And you will have to still do the pre-lab questions and the post-lab questions. And then you will have to submit it online to me. So I think the way that's going to go is I will, on Canvas, make an assignment called Experiment 7. And the way that you submit for Experiment 7 would be to, however is best for you to do it. You could take pictures of it. You could scan it in if you have access to the scanner. I know now there's a lot of apps on phones that will take pictures and kind of make them like a PDF file. You could turn it into a PDF file. However is sort of easiest for you to sort of do that. And then there will be a due date like normal. And before that due date, obviously, you just log on to Canvas and click on that assignment. And then it'll ask you to upload those files. So hopefully, if you can, just for my sake, if you could kind of put it all together in like one file, that would be great. I understand if you can't do that. So if you could do your best, just so I don't miss anything. But I think you could pretty much upload any type of file in Canvas. So again, it could be like a PDF, it could be a text file. I don't think that'll work well for a lab report. So it could be any of those type of files. It could be pictures as well. So that's sort of how the submission process for the lab will be done. So pretty much experiment 7, you're still going to kind of look at it as a formal experiment. You're still going to have to write in your lab notebook what you're observing in the video, along with obviously recording all the data that he gives you. And then obviously you'll need to do the calculations for that, and obviously type up a lab report, much like the hydrate lab report was. So again, that should consist of the pre-lab questions, the type lab report for experiment 7, and then the post-lab questions and your carbon pages. So I will need a sort of a copy included of your pages. Yeah, so experiment 7 again is going to be a video, and there's a lot happening, as I imagine, with you as well. This last week has been a little crazy. All my classes at all my schools have went online and stuff like that, like over the weekend. So I haven't had a chance to kind of post all that stuff up. My hope is in the next day or so, I will post it up on Canvas, a link to where you can find the video, so you don't have to just go search for it. So I'll post it up on Canvas with an actual sort of something written that explains what you need to do for the experiment and sort of when it will be due and stuff like that. I guess it'll be due in a little bit. That way, maybe after some people get a chance maybe to look at the video and stuff like that, maybe next week during lab, time, we'll open up a meeting here for lab. And again, if you have questions on sort of the calculations or that type of stuff, again, you can get help during the lab time. So all the rest of the sort of formal labs will probably be done that way as well. Not even the formal labs, just the regular labs as well. I think we got, for example, I think double displacement reactions that's coming up, which is not a formal lab, and maybe some electrochemistry type ones, redox ones. So those, again, hopefully will be sort of videotaped for you. You'll have a link where you could go and you'll have a link where you could go and watch all those videos and kind of fill in the data sheets. So if we have a sort of non-formal lab, which I think we have a couple coming up in the next few weeks, again, the same thing will happen. It'll be a video. You'll go there, you'll fill it in, the paper just like you would do in class. And again, you'll just have to kind of transform that paper, either scanned in and convert it into some type of file that you could upload, on Canvas when that due date is there. Yeah, that's a good question. The question is about the Star Center. So again, since they're not truly allowing anybody on campus, the last thing that I saw in terms of the Star Center, and I don't have a good update on that, is that they were still trying to sort of work it out that they can maybe open through this type of service, so either you'll be able to conference with them, just like we're doing now. They might let you use the video if you want that aspect of it. But that was my last understanding in terms of what they were trying to do with the Star Center, was to maybe kind of open it in that sense through some type of conferencing software like what we're using here. And that's sort of the last I've heard about it, but that my guess is something like that will be hopefully opened, and at least you'll have access to it at some point. Other questions? It has been really hectic is an understatement. Truthfully, I barely had a chance to do much in terms of all that. My hope is by next week I'll get some of that stuff up there posted. The question was about exam one. Um, I remember you did take exam one. It seems like a long time ago, but yeah, unfortunately, it's been really busy, and I haven't had a chance to kind of update that. And I will try to get that done sometime, at least by next week. So hopefully you'll have your exam one score there. Other questions? Yes. Yeah, so I'm not familiar with what Discord is, but I'm assuming it's a similar type of system of what we're using here, some type of conferencing software. Um, so physics and math looks like it's available that way. Again, the last I heard, they were trying to figure out some way to do that with the Star Center, I think, for chemistry as well. And maybe even, although we don't have SI in our class, I think they were also trying to figure out something to do with supplemental instruction, SI type of things as well. Other questions on that? Okay, so that's essentially how lab stuff will work. So for example, I know most of you still have the study assignment B, which I think is about Lewis structures and stuff, which I think was the last stuff we were talking about. That also will be submitted online in the same fashion. So again, you'll have to kind of convert that into some type of file that you can, again, hopefully upload. And I think right now, if you go to your Canvas site, or later when we're done, and you look at it, you should be able to see under the assignments tab one that says SAB, which would be study assignment B. And there is a due date. I think I made it for next Friday, I think, and stuff like that, because I believe we talked about almost everything that's on there. So if not, tentatively that's when it's scheduled to be due. So at the end of Friday, I think 11:59, you need to try to upload that. And again, tentatively that's when it is, but do try to get it in hopefully by then. Any questions on sort of how the lab portion is going to work? And obviously for study assignments, they should hopefully correspond to some of our lecturing. Um, and my goal on those is kind of, like I said, just to open up a separate lab conference for lab time. And again, I'll just nothing really too formal, especially on those study assignment days, but I'll just be there at the beginning and all that kind of stuff, hanging out. And just like normal, you usually would come up to me and ask me a question. Again, during that time, you could either ask through your mic if you want, or you could type a question. And again, I do have sort of access to, like something to kind of scribble on and stuff like that on the screen. So I can kind of get something out for you, like I was working out, for example, like on the whiteboard and stuff like that. So you'll be able to see that. Any other questions in terms of how the lab's going to go? In terms of due dates and stuff for labs, again, there will be due dates. You should try to obviously get it in on those due dates. I understand there's a lot going on for you as well. So, we'll be flexible as best as we can. Yeah. But at some point, you still have to do the work and sort of get those assignments in. Okay. Now, in terms of, it's a very good question in terms of how exams will be done. So I guess it's good. We just took exam 1. So I think we've got a little bit of time before exam 2. But I'm still really working that out. My best guess is I don't anticipate, and again, it's just my idea here. I don't anticipate that we'll probably be back in person on campus, maybe before exam 2. So my guess is it probably will occur some version of an online exam. Also, it might be done through Canvas. I haven't 100% sort of worked out those details. I'm trying to work those details out for all my other classes as well, but there will be some type of online version of it where perhaps, again, one option may be an online version through Canvas, where maybe you do work out your work on a piece of paper and then you have a certain amount of time to submit that work like you would do on the exam. So that could kind of give you partial credit and look at your work in case you do get the answer wrong. So I'm still working those things out. Again, I don't want to really commit to one thing or the other, but I don't really feel good about giving you just a online exam where it's all multiple choice, so it's all or nothing. I still want to hopefully have some way to perhaps give you some partial credit or something like that. So my thought process is maybe some type of combination of an online, and maybe you still do the work on a piece of paper, and much like all your other sort of assignments, you submit that right after your exam, and at least I could kind of look at your work. And again, if you click the wrong button or enter the wrong answer, at least I'll have a way to perhaps give you some partial credit on an exam. So you have to kind of stay tuned in terms of the exam. Again, still sort of working that out. But if I had to guess, it's going to be some type of online type of exam that will be given. Other questions on that? Quizzes will also be similar. I would assume as well. It will be sort of an online quiz. Would probably be done in a similar type of fashion. Other questions on exams, quizzes, or that type of stuff? And then obviously on those exam days or whatever days we would take the exam, if we're still obviously doing everything online, the homework would be submitted just like any other assignment. You'll have to, take pictures, convert it into a PDF, scan it in or something like that, and then has to upload it at a particular time and date. Other questions on anything on that? Okay, now in terms of lecture, so normally I give you the lecture notes as handouts and stuff like that. So what I will be doing now, and I did put up, I think, a couple of them already on our Canvas site. If you go to our modules section, let me just see here. I'm going to stop sharing that screen with you for just a second. And here. Too many options. Let's go to that one. All right, so hopefully you should be able to see this is basically our canvas site. And again, where is that thing? There it is. That's where we're at right now. So hopefully you can see this. So if you go in the modules section, again, I made a little guy here, lecture notes. So this is chapter 4. I made a new one for chapter 4. A little bit of what we had left was basically molecular polarity and that type of stuff. So I made a slightly different one than the one you have. It kind of has sort of the same stuff. I also made one for the next chapter, which is chapter 5 here as well. So again, you could still print these out. You could open them up on your whatever you got going there and kind of electronically take notes with them as well. So this is where, again, you'll be able to find the notes for the lectures as we'll be doing them online. Here as well, hopefully some of you maybe saw, in case you can't get to the conference Zoom part or whatever it may be, there will also be a secondary link to find our lectures, our live lectures, and also we'll have one for labs as well that will be up in this section. Again, these things will start live at our normal time. Also, once we're kind of going here and have some videos to record, I'll make a section in this area as well where you could click to basically look at the recorded videos for both. I think I'll post probably the lecture and the lab ones if there's stuff pertinent in lab, or I go over some calculations for some people. I'll post those as well up here. And at the moment, what I'm going to do is post those guys, and I think I'm just going to make them sort of embedded inside of Canvas, where you just have to go to Canvas essentially, and you can watch it right there. You could probably download it as well if you wanted to. And that's sort of where we'll find those things. So you want to make sure that you keep checking those sections as well. Again, any type of new lecture notes will be found over there in that section, and also in the module section. I'm going to try to put all this stuff towards the top. You'll be able to find all the links to the live ones, lectures, and labs, and also the recorded videos. Any questions on that there? Any questions in general about the class or how things are going to proceed from this point forward? Everybody's doing okay in terms of technology. We could hear everything. Okay. So since we're all here together, I guess what I'd like to do today is I'd like to really finish up the chapter that we sort of left off on, which is that chapter 4. And again, just to kind of finish covering all that bonding information. And then that hopefully will allow you to have enough information to essentially be able to complete study assignment B, which was that Lewis structure study assignment. So again, what I'm going to be using in terms of the notes here are kind of the new ones that I made. And again, they're kind of the same information that you got on your ones that I gave you in class, but they're just slightly different examples. And if you want to see the actual ones, they're there. Just to let you know, as I project these slides through the slideshow, and when it records, you pretty much could just watch the slideshow. You'll see everything that's on the screen, all the slides, everything that's filled in. So, this could be better for you to just listen, or if you want to take some regular notes like normal, you could do that as well. And then just use the videos if you want to sort of review what we went over. But again, you can do it either way. Pretty much everything that you see on the screen that I capture for you, you should be able to also, again, see in that video once it gets recorded. So again, if you feel like you missed something, you probably will be able to find it if you just kind of go back and figure out where it was. Any questions on any of that before we sort of begin? Okay, so we were kind of in the middle of chapter 4, towards really the end of chapter 4. We were talking about bonding. And in bonding here, we went through pretty much all the geometry. So when we talked about the geometry, remember that you are responsible for both the electron pair geometry, which describes the geometry of how the electrons are around the central atom. And you're also responsible for the molecular geometry name, which is essentially the shape of the molecule. And remember, in certain cases, as we talked about, when you pretty much draw the Lewis structure and you have no non-bonding electrons around that central atom, you will have the exact same name. So the electron pair geometry name and the molecular geometry name will be the same. So for example, grab something here to write with here. So for example, if we had CH4, and I apologize, I'm just trying to use my mouse here. Pen is on its way, I suppose. So if we do something like CH4, and if you remember, when we look at something like CH4, it has 1, 2, 3, 4 electron pairs, and it also has 4 bonds. And you'll be able to see all the stuff that I'm writing on the screen as well, in the video as well. So it'll come up in those videos that get recorded. And again, when we talk about the electron pair geometry name, that is going to be tetrahedral. And the molecular geometry name will also be tetrahedral, again, because we don't have any non-bonding electrons. It's only when we introduce those non-bonding electrons, so if we take something like water that we talked about, and when we take something like water and we look at the center atom still has 1, 2, 3, 4 electron pairs. So something with 4 electron pairs, just like it was above, in terms of electron pair geometry name, will still be tetrahedral. But it's because now, though, when we look at that central atom, we now have all those electrons interacting with each other. So as we talked about, when we have bonding electrons near bonding electrons, or non-bonding electrons near bonding electrons, and non-bonding near non-bonding electrons, there's 3 types of electron sort of interactions that occur. And really the worst interaction in terms of electrons not want to be near each other is really those non-bonding electrons near the non-bonding electrons. So again, because we have these non-bonding electrons near those non-bonding electrons, they try to spread out as far as possible. And what ends up happening for the molecular geometry name, we actually end up getting a different name, which is bent or V-shaped, right? So when we talk about geometry, we have 2 names: electron pair geometry, molecular geometry, which again is sometimes just referred to as the shape. And they are the exact same name when we do see no non-bonding electrons around the central atom. And the names differ when we do start to see these non-bonding electrons. The name that really doesn't change, regardless of the type of electrons that are around the central atom, is electron pair geometry. So if you have 4 electrons, it's going to be tetrahedral. You got 3 electrons, it's going to be that trigonal planar. You got 5 electrons, which is that expanded octet that we talked about. That was a triangular bipyramidal. You got 6 electron pairs, that would be octahedral. So the name that does change, again, because of those non-bonding electrons, is going to be that molecular geometry name. And it's because you have that different types of electrons interacting with each other. And because all electrons are negatively charged, they ultimately don't want to be near each other. So they try to spread out as far as possible as they can. Any questions on that type of stuff we were talking about there? I think at the end. And I think also at the end, we tied in the idea of another sort of bonding sort of idea, which is known as hybridization. And in hybridization, if you remember, it is really the idea of bonding. And it's an idea of bonding that allows us to understand why we see certain bond angles when we look at these molecules. The sort of valence shell model or Lewis model here doesn't necessarily account for the bond angles that we associate with these molecules, but hybridization sort of accounts for those bond angles that we see. And hybridization is really, again, just to simplify it, is the idea when we take these atomic orbitals, for example, like s orbitals, our p orbitals, and our d orbitals. And again, all these guys are atomic orbitals, right? Now, when we make hybrid orbitals, what we end up doing is we basically are combining 1, 2, 3, 4, 5, 6 of these atomic orbitals to make these hybrid orbitals. And the idea behind that is that these atomic orbitals by themselves, if you remember, they all have sort of different shapes. So for example, an s orbital, sort of a spear, p orbital sort of looks like a figure eight, and so forth. And all these guys, in terms of energy, they're all at basically different energy levels. And when they do come together, you got a lot of different type of mixing of those orbitals, which may not account for those geometries that we see, because we got circles mixing with, figure eights, if you will, in terms of shape. We got one guy that's a little bit lower in energy, one guy is a little higher in energy. So when these guys go through hybridization, what they essentially do is make these hybrid orbitals. So for example, if we took an s orbital and a 1p orbital, and it goes through hybridization. When we do go through hybridization, what ends up happening is we will make 2 hybrid orbitals, and the number of hybrid orbitals that you make is always equal to the number of atomic orbitals that you combine. So in this case, since we're combining an s and we're combining a p, what we will end up making is 2 hybrid orbitals. And these are both named just like we just talked about here, S and P. So these are both sp hybrid orbitals. And the nice thing about these hybrid orbitals are they're both basically the same shape. They're also both the same energy. And that allows for better orbital to orbital sort of overlap that occurs. And that allows us to get those sort of bond angles that we see. We also see, though, if we look over here, that we have 2 p orbitals that pretty much were unhybridized. So in addition to those hybrid orbitals on the bottom, we would still have, this would be our py unhybridized orbital, just like a normal p orbital, and our pz unhybridized, just like a normal p orbital would be. Remember that as we talked about quantum numbers and all those kind of things, this is essentially your px orbital, right? Your py orbital and your pz orbital, with our m sub l of -1, 0, and +1 as we go across here. So this allows for sort of bonding to occur between these hybrid orbitals. Any questions on that aspect of it? Okay. So we also got through sort of the different types of hybridization that occurs, and they are related. When we talk about hybridization, they are related to the actual electron pair geometry, if you remember. So the electron pair geometry is what the hybridization is really based on. So let me just go to the next page, get something fresh to write with. So if you remember, when we have basically two electron pairs, that is the geometry that is basically linear. And what I'm going to do is move some boxes out of my way. There we go. So we'll have our S over here. We'll have our 3P guys over here. That's a big P, huh? 1, 2, 3, 4, 5, and D. There we go. So basically, the simplest way to figure out hybridization is you want to count electron pairs. Yeah. And when you count these electron pairs for hybridization, you still want to count it like we did for geometry. So if you remember when we did Vesper, which is a geometry, the main thing when we're counting electron pairs is if it is a double bond or a triple bond, it counts as only one electron pair. So that's still how you want to count it when you're kind of doing hybridization. So if you count two electron pairs, you always start at the bottom. So 2 would be 1 here and 1 here. So we basically combined an S and a P. So this should give us SP hybridization. Now, if we have 3 electron pairs, that's our trigonal planar. And essentially, the simplest way to think about it is to even write this right here, like I did right over here. I'll kind of create that on the paper for you. And basically just count. You always start at the bottom. So 3 would be 1, 2, and 3. So I use an S and 2 P's. That will give me SP2 hybridization. 4 electron pairs will give me my tetrahedral in terms of my electron pair geometry name. And again, 4 basically means 1, 2, 3, and 4, which means the hybridization would be SP3. So this would be SP and 3. Any questions on that so far? And again, these cover pretty much our guys that will obey the octet rule. Now, as we talked about, we do have some exceptions to the octet rule. And the first one is the expanded octet. So that would be 5 electron pairs around it. And that basically means there's a total of 10 electrons. And that is our triangular bipyramidal. And again, if you're thinking about sort of the hybridization, you want to start down here. That's 1, 2, 3, 4, and 5. So that expanded octet gets us into those d orbitals. And as we talked about, that is really why they're able to go past 8, is because they have those d orbitals available to them. So again, 1, 2, 3, 4, and 5. The hybridization would be SP3, again, because we use 1S and all 3 of the P's. And then we also use one of the D's, and it would be D as well. And the last one is 6 electron pairs, and that is related to our octahedral. And same idea, that is an expanded octet, which again means that it has more than 8 electrons. It has 6, which is 12. And again, if you want the hybridization, just start at the bottom. So that's 1, 2, 3, 4, 5, and 6. So we essentially use 1S, all of the P's, so that's 3 P's, and we got through 2 D's, and that will give us our SP3D2 hybridization. Any questions on the relationship between hybridization and electron pair geometry? Sometimes people get a little crazy with it and think it's like way complicated. If you keep it simple like this and just pretty much count the electron pairs, starting at the bottom, working your way up, you'll pretty much get the right hybridization always. You can apply hybridization to the center atom. You can also apply hybridization sometimes to an outside atom. And again, what you're looking at is just the total number of electron pairs. They could be dots, they could be lines. If they are lines and they're double bonds or triple bonds, again, they count as only one electron pair. Any questions on that? So, for example, if we look at something, and again, I apologize for my best here with the mouse. So, for example, if we look at, say, a compound such as this, I'm just going to kind of draw it this way. So we basically got two carbons, which are double bonded to each other, and both of the carbons have a hydrogen on it. We could apply hybridization to each of the carbons. So if we look at, go green. If we look at this carbon here, and really just from the actual Lewis structure that's drawn correctly, we want to count the number of electron pairs. So if I look over here, we have one electron pair here. We have two electron pairs here. And again, this double bond counts as one more, which is going to be 3 electron pairs. And that means that that would be up here. And this hybridization would be sp2 hybridization. Any questions on that? Okay. So if we do the same thing on this guy, we got pretty much the same deal. We got 1, 2, and again, this guy counts for it, which would be 3. So this guy would also be sp2 hybridization. Yeah? Now, in this case, and in most cases, hydrogen will not go through hybridization because it pretty much has only one electron. So hydrogen does not go through hybridization. Yes, you do have to consider the double bond when you're doing hybridization or any type of geometry. Double bond or triple bond counts as just one electron pair. So essentially, when we look at each of these carbons, for example, as well, in this case, we actually have 2 different central atoms. And when you have 2 different central atoms, you actually can do the geometry for each of these guys separately. So for example, if we did the guy right here, we would essentially put our hand over this part of the molecule, and it would have 1, 2, 3 electron pairs, and it would also have 1, 2, 3 bonds. So the molecular geometry on this guy would be trigonal planar. And also the electron pair geometry would be trigonal planar, as we talked about, which also obviously works with sp2. And then what you would do is you would come over here and basically put your hand over this side of the molecule, and you would still count like we just did 1, 2, and 3 electron pairs, which means this side also would be trigonal planar. And that name would go actually in this case for both the electron pair geometry and the molecular geometry name. Again, there's no dots around these guys, so there's no non-bonding electrons, which means the electron pair geometry name and the molecular geometry name will be the exact same thing. So these guys will be the same in this case on both sides there because we have no non-bonding electrons. Questions on that? So when something like this goes through this hybridization, and what I'm going to do is I'm going to go to the next page and redraw this guy, so I got a little bit more room to kind of work with here. So if we come back to our guy that we had drawn, which is our carbons here and our hydrogens. And again, a reminder on the video, all this stuff I'm really badly scribbling up here. You'll be able to see all that stuff. So again, we have our hybridization for this carbon, which is sp2, and we have the hybridization for this guy, which is also sp2. So kind of like what we were talking about the other day, in terms of what's sort of happening is if we take the carbon, and again, carbon, if you look on the periodic table, carbon there is group number 4, which means it has 4 valence electrons. So when we look at carbon, because we know, for example, the carbon over here on the left-hand side, and what I'm going to do is I'll just call it left over there. We'll call this actually carbon 1, for example. We'll call this guy carbon 2. If I look at it, because this is sp2 hybridization, what's going to happen is this guy is going to have 2 sp2, and 1 more makes 3. Glad I know how to count. That's good. There you go. And the reason we would have 3 hybrid orbitals that's made for the carbon is because, again, we're going to take 1, 2, and 3 atomic orbitals. That will give us 3 sp2 hybrid orbitals. That will also give us 1 pz orbital that is unhybridized. So where all these guys come from is both of the carbons in this case is exactly the same. So before it goes through hybridization, carbon has got 4 valence electrons in its s, and it's got 1, 2, and 3, and then it's got these guys here. So if you remember when we were talking about before we left, through the process of hybridization, that electron is going to make its way to the guy in the higher energy level, and we will then end up with 1 electron in each of those. And our S down here. And again, at that point, because it's going to go through that sp2 hybridization, this 1 s orbital and those 2 p orbitals is essentially what's going to make each of these hybrid orbitals over here. Yeah? And we can see each of these orbitals have 1 electron in it, and that means that I missed the orbital there, but imagine it made it in the orbital. Each of these guys will end up with 1 of those electrons. Now, what's left, as you can see, when it goes through that hybridization, is we have this 1 p orbital over here that does not go through hybridization. So that is our guy that ends up right here. And he also, as you can see, has an electron up there in his p orbital. So what we have here is all for carbon number 1 over here, this guy. Yeah? Any questions on sort of where all the electrons went? Now, because the guy on the right here, carbon number 2, is also sp2 hybridization, it's essentially going to go through the exact same process for the second carbon that's there. And he also will end up with this exact same arrangement. So carbon number 2 over here will end up with 1, 2, and 3 sp2 orbitals, each having an electron in them. And it will also end up with that unhybridized, again, not drawn perfectly in terms of energy, they should be kind of equal, pz orbital that is unhybridized. So this is sort of how all these electrons end up as they're distributing from each other. And if you remember, slap that over there. Sorry, I just got boxes in my way, so we should move some boxes out of the way. So if you remember, when we look at our guy here, we're going to make some bonds that are going to occur. And one type of bond that we talked about, I think at the very, very end of lecture when we last were together, was referred to as a sigma bond. And sigma bond, again, sometimes symbolized by that. And really what a sigma bond is a type of overlap that occurs with orbitals where it is sometimes referred to as head-to-head overlap, which basically means they shoot right at each other and they overlap areas where those electrons are basically going to be shared. And the simple sort of way to think about a sigma bond is it's essentially all single bonds. Yeah, anything that's basically a single bond are in the sense a one line that's in the structure is going to be a sigma bond. So we have in this particular structure, what's going to happen is each of these hybrid orbitals here, for example, they are able to make a sigma bond with a hydrogen. And remember that hydrogen essentially only has a 1s electron. So for example, I'll just draw this only one here. This carbon and hydrogen basically will come together to make, say, this bond right here. And that will give us a sigma bond that occurs. This guy will bond to another hydrogen. On this side, you have the exact same thing happening. You have this guy, for example, coming down to a hydrogen. That's 1s. Say that represents this bond. And you have another one that's coming down to a hydrogen. That's a 1s. Again, sharing of electrons, which would represent, say, this bond here. You have this guy here represents this bond. This guy is also representing a bond with hydrogen, which would be here. And what we're left with in this case is these two guys will also come together to make a sigma bond. And that is a sigma bond between a sp2 of carbon 1 and an sp2 of carbon 2. And I'm just going to highlight this guy here. We'll call it that bond right there. So this guy right here would say, for example, be the bond that we have happening right there. And if you kind of look, we've used this, we scribbled here, we've used this electron, we use this electron, this electron, this electron, but we still have this one bond underneath here that still needs to be accounted for. And that bond occurs from the only electrons that we have left, which are these electrons here. And these electrons here will be shared. And these are our unhybridized electrons, our unhybridized orbitals. And when these guys come together, they actually come together and make what is known as a pi bond. So a pi bond would account for the double bond that we see here. So this way here. When we look at that pi bond, the type of overlap that happens in a pi bond is actually different than what happens in a sigma bond. Because those p orbitals up there, and I'll do my best to draw, are unhybridized, they still look like p orbitals. So the kind of that figure 8. So this is our pz orbital in carbon number 1. And this is our pz orbital in carbon number 2. And what ends up happening when these guys overlap is they overlap this way, which is sometimes referred to sideways overlap. They basically overlap above and below kind of the plane of it, and that gives you your double bond that occurs. And that's what's known as a pi bond. Any questions on that? And again, you're not going to be asked to draw all these arrows. Before it got all scribbly, it's supposed to hopefully help you visualize where all the electrons sort of went to. But you will need to be able to identify sigma, pi type of bonds. Questions on how a pi bond is formed. So really, a double bond consists of a sigma bond, which is here, and that is this guy right here, and also a pi bond, which is the bond that occurs between those two guys. Any questions on that? So let's just kind of look at sort of the application of how you would do it. So looking back at that molecule that we were just looking at, if we want to know the total number of sigma bonds in this molecule, how many sigma bonds would we have in this particular molecule? What do you think? Well, we should have 5. So let's see if we're right here. So this is basically a single bond, which would be a sigma bond. So that is 1 right there. This guy right here is basically a single bond, which would also be a sigma bond. So that's 2. Between carbon and hydrogen here would also be basically a single bond, which would be a sigma bond. And between carbon and hydrogen here, that would be a sigma bond. So that is 4 sigma bonds. Now, if you remember when we were kind of watching the electrons, there's also a sp2 orbital and sp2 orbital that's going to come together and essentially make like a single bond. And that also would be a sigma bond. And that would give us 5 sigma bonds in this case. And as we saw when we were looking at the electrons, this double bond is consistent of a sigma bond. And then what we will have here is a pi bond that basically will occur. So this second one that makes that double bond is a pi bond. So this particular molecule here would have 5 sigma bonds and 1 pi bond. Any questions on how to identify that? So let's take a look if we take a look at another one here. For example, let's take a look at this one here. Good thing there's an eraser, huh? There we go. Try that again. So pop, and so what I want you to figure out, and just take a second, I want you to give me the hybridization for, we'll call this carbon 1, carbon 2. For carbon number 1, carbon number 2, I want you to give me the hybridization for the oxygen in the double bond, if we apply hybridization to that. And I want you to give me the hybridization of the oxygen in the single bond. So take a moment and work through that. And then I also want you to figure out how many sigma bonds are there in the entire molecule and how many pi bonds are there in this entire molecule. So take a couple of minutes and figure that out, and then we'll talk about it. Okay, so let's take a look here. Let's take a look at carbon number 1. So we'll start with the hybridization. So when we look at carbon number 1, again, we want to count how many electron pairs like we're doing electron pair geometry. So we have 1, 2, 3, and 4 electron pairs. So again, 4 electron pairs would be pretty much 1s and 3 p's, right? So 4, basically 1, 2, 3, and 4. Any questions on that one there? Yeah. Our carbon number 2, when we look at the hybridization, we will have 1 electron pair, 2 electron pairs, and again here our double bond would only count as 1. So that would be 1, 2, and 3 electron pairs. So 3 electron pairs would be sp2. Again, basically the number, right? 1s and 2 p's is 3. Yeah. When we look at our oxygen, if we decide to apply hybridization to our oxygen here that's double bonded, we will do the same thing. We have 1 electron pair here, 2 electron pairs here, and again, the double bond would only count as 1. So that is 3. And that also would be sp2 hybridization. And lastly, if we look at our oxygen here, it is 1, 2, 3, and 4, which would be sp3 hybridization. Looks like we're getting some of the right ones there, looks like. Any questions on any of those hybridizations? So again, sometimes you can apply hybridization, not necessarily always to the central atom. You can apply it to the outside atom as well. And sometimes we'll explain some of the geometries that we see occur in a molecule. Any questions on how we got any of those? So again, now we want to look at sigma bonds. So pretty much wherever you see sort of a first line drawn, you can kind of think of it as a sigma bond. So this is basically a sigma bond. This is also a sigma bond, so that's 2. This is 3. This is 4. This is 5. This is 6. And remember, as we talked about in our double bond, we essentially have a sigma bond as well. So I believe that is correct. That should be 7 there, if I counted that right. 1, 2, 3, 4, 5, 6, and 7. And again, that's going to be, we can even get very specific about the bonds, the orbitals that are happening here. So for example, if we looked at that carbon oxygen double bond, even without drawing arrows or any of those things like we did previously, we know that this guy's hybridization, as we have down here, is sp2. A little out of control marker there, sp2. And we know that the hybridization of this carbon that we have here is sp2 as well. So without doing any of those arrows, we could say that this sigma bond is basically a sp2 hybrid orbital in oxygen that's bonded to an sp2 hybrid orbital in carbon. So just by knowing the hybridization, knowing the type of bond, you could say that these 2 orbitals are the ones that are involved in the bonding. Any questions on that there? Now, when we look at that double bond, within that double bond, we still have one more type of bond there. And this is going to be our pi bond that occurs right there. And that pi bond, again, is from that unhybridized p orbitals. So again, it's the p orbitals that are unhybridized that do the sideways overlap. And what we know is when we look at this guy, since these are sp2, because we use 2 of the p orbitals here, we know that this orbitals that are unhybridized is actually the pz orbitals that are involved here, because that would be the only p orbital left because we used 2 of them. Because if you remember, when we went through hybridization, to get to sp2, you would need all those. and that's our px or py, and that would leave our pz orbitals unhybridized in this case. Any questions on how to identify sigma bonds, pi bonds, hybridization? To sort of summarize your sigma and pi bonds, if you have a single bond, it is basically going to be a sigma bond. If you have a double bond in a Lewis structure, it is going to be made up of two things. It will be made up of a sigma bond, and it will also be made up of a pi bond. We'll change the color of this guy. And if you have a triple bond, so if you remember, if you draw a triple bond there on a Lewis structure, you will have 1, 2, and 3 bonds. And same deal, you will end up with first one, for example, a sigma bond, and you will actually end up with not 1, but 2 pi bonds. And the reason for that is, for example, I guess over here we had just 1 as the answer. If we look at, say, a carbon-carbon triple bond, if we were to do the hybridization for the carbon there on the left, what would be this hybridization right here? How many electron pairs are around this carbon? This one would count as 1, and this triple bond would count as 2. So there is actually only 1 and 2, which means the hybridization here is SP, yeah? So the actual hybridization there is going to be SP on that one. Same thing if you come here, it has 1 electron pair, and again, this, even though it's a triple bond, going to count as 1 electron pair. This also would have 2, which would be SP hybridization. And SP hybridization goes with 2 electron pairs, which is essentially linear. So again, if you put your hand over this part of the molecule, 1, 2 electron pairs, 2 bonds. This is basically a straight line all the way across because it's linear. And when we do SP hybridization, because we are only taking 2 atomic orbitals, that means that we will end up with 2 SP hybrid orbitals. But what we will end up with is actually, in terms of p orbitals, we'll end up with a py orbital that's unhybridized and a pz orbital that's unhybridized. And this carbon will have pretty much the exact same deal. It will also have those 2 p orbitals, the py and the pz orbital, that are unhybridized, and it will also have its sp hybrid orbitals. So if we just sort of count the bonds, if you will, this is basically carbon and hydrogen, and that's basically when this has an electron in it, it's going to make a bond to hydrogen. This is also carbon and hydrogen, which would make a bond over here. Now, when we look at the triple bond, it's made up of what we have left in here. I didn't draw the arrows in because it's getting kind of crowded, but basically we're going to have a sigma bond that's going to happen between these two. So we would have a sigma bond. And now what we would have is a pi bond between those two, which would be, say, this bond right here. And we would have a second pi bond between those two, which would be here as well. So what you have in a triple bond is you have 1 pair of p orbitals that are overlapping. And I'll just draw it separate. You have a second set of p orbitals on another axis there, very badly drawn, that are also overlapping. So this accounts for one of the p orbitals. This accounts for the other p orbital overlap. So this is a pi bond, this is a pi bond, and you have a sigma bond that occurs there. So again, if you don't have to worry about sort of all the pictures and all that and all the arrows and stuff like that, if you pretty much remember this, anywhere you got like one line in a Lewis structure, going to be a sigma bond. If you have two lines for a double bond, one's a sigma, one's a pi. And if you have three lines for a triple bond, one's a sigma and two pi bonds. Again, one being the py orbitals overlapping and one being the pz orbitals overlapping. Any questions on that? So I think that's a good place to stop for our first sort of online lecture. We didn't get to polarity, so I may move the due date for that as study assignment B. We definitely will get to polarity on Tuesday, and we'll go over all that kind of stuff. And we will start rolling into the next chapter, which is chapter 5 as well, on Tuesday as well. So again, just a reminder for some people that maybe came in a little bit late, just to kind of summarize everything that's sort of going to be happening every week that we would technically be in class. We definitely will have a lecture on Tuesday and Thursdays. The live lecture will again occur pretty much the same time as our normal class at 5:30. You'll find the invitation either in the Confer Zoom part of Canvas, or again, just a separate page as well, like a link to it in the Canvas site for you to join in. Again, I would recommend trying to join in the live one so you could, again, ask your questions. And if you have questions, hopefully get them answers. On days where we're maybe doing labs or something like that, or we may have some lab questions, I will have a separate meeting for that. And after technically the lecture's over, we'll take a little break like we normally do. And I'll again open up that second meeting for you to ask questions in terms of any type of lab calculations or really anything, to be honest with you. You can ask about lecture stuff too, it don't really matter. But mainly it'll be for the lab stuff. But if you have questions on anything, you can get some clarification. And again, we'll kind of leave those sessions like that. In terms of actual labs at this point, again, you should have study assignment B, which is the Lewis structure one. And again, we didn't get to the polarity part because we kind of reviewed and talked about the class and all that kind of stuff. So we'll get to it on Tuesday. So right now it's due next week on Friday. I think you probably should still be able to knock it out, but I'll probably give you a couple more days to make sure that you have enough time to turn that in. Again, all lab assignments and pretty much all assignments at this point will be submitted. And at this moment, and again, things could change, but at this moment, it will be submitted through Canvas. So whatever assignment it is, there'll be an assignment that's made in the assignment section of Canvas. And then you can upload it in some type of file format for me to obviously look at. And the next day, hopefully by tomorrow, or at least next day or so, but probably by tomorrow, or maybe even tonight, I may try to do it if I can. I'm going to post the link up on Canvas for experiment 7, which is technically the experiment that we're going to do this week. And again, we're only technically going to do part 1, which is silver chloride, and that is all he videotaped, okay? So again, you need to go and follow that link, essentially. You need to kind of fill in the information in your notebook like you would. That includes procedure, that includes calculation, table, observations of what you're seeing. And again, this will be a formal lab report. So you want to think about the calculations and stuff like that. Again, some of those calculations we might not have got into. It is the start of the next chapter, I think. So you might need a little bit of help on that. And again, next week we'll try to get into that stuff and go over that. I don't anticipate that lab report will be due for a little bit since we lost like a day or so here in terms of lecturing. So obviously it won't be due next week, and it probably won't be due the following week. It might be due towards the end of the following week at the earliest would be my anticipation. we're still going to treat it as a formal lab, even though you didn't physically do it. You're going to watch it and still have to type up a formal lab report like the hydrate lab. And then all future labs that are technically hands-on labs, my understanding is there will be videos posted for you to watch, get the information, and then be able to complete the labs. Any questions on any of that stuff? Okay. Just as like normal, I still have my email, yeah, just thousands of emails coming in. But if you still need me for anything or you want to just contact me, you can definitely still shoot me an email. I check pretty regularly throughout the day. I'll get back to you and stuff like that. Yeah, same thing again with the hydrate lab and the hydrate lab and exam one. Again, I got a little backed up with pretty much everybody deciding to go online kind of last week and stuff. So I'm going to try to catch up on all that and hopefully have those grades up. And obviously at this point, they would be posted up on Canvas. My hope is by sometime next week, I'll have some of that. Yeah. So as of now, in terms of the lab schedule, we're going to sort of follow the same lab schedule. So definitely for what's coming up in terms of the study assignments and stuff like that, we're going to stick to the same lab schedule. And again, that's the revised lab schedule that you can find on Canvas. So not necessarily the one that was in the syllabus. I think at this point, it's not too much of a difference between that one and the ones on Canvas, but make sure you check the one that's on Canvas. It's just say revised lab schedule. And we'll follow that for the time being. Again, there may be some changes tentatively to the scheduling. And again, it's because Professor Wada is pretty much kind of making the videos for those labs. So, he's got a lot of classes and stuff to do as well. So I'm not sure exactly how quickly he's going to get all those sort of videos made and out to us. So we may have to adjust some of the lab schedule based on sort of the availability of that. But in terms of study assignments that's on the lab schedule, we'll try to maintain some of those. And again, the due dates will probably be pushed off a little bit on some of those because we obviously are a little behind the lecture because we lost some days by kind of transitioning and stuff like that. So that's why, again, you might want to show up for the lab kind of conferences when we do, so you have some questions. And over the weekend and stuff like that, I'm going to think about it. And, there may be some times that we may do a little bit of lecturing through lab time just to maybe catch up on some of the stuff that we need to get to. But you want to make sure that you do kind of come to those labs. So there's a couple of questions about study assignment B. As of now, before we started lecturing, my hope was to maybe get through the polarity, but I kind of went over a lot of the stuff that we talked about, I think, the last time. So my hope is to get through polarity today and give you sort of the week to make it do. I think what I'm going to do is I'm going to push it probably in the next day or so. I'll probably push it to the following Tuesday, and that should give you plenty of time. Again, if you finish it before that, you can submit it anytime up until next Tuesday, but I'll do that way. That way we're going to definitely get through polarity on Tuesday. We obviously should have less sort of business stuff to talk about. We can kind of get right to lecturing. So we'll get through polarity, and then we'll get into chapter 5, which is a lot of the sort of study assignments that are coming next week. So in terms of lab, I think we're not going to meet for that tonight officially. So I'm not going to open another meeting or anything for lab. At this point, I would try to focus in on finishing up study assignment B or as much of it as you can. And then, like I said, later tonight, hopefully I'll post sort of the information for the lab, and at your convenience, obviously you could go watch the lab video and stuff like that, and we'll just call that lab for tonight. And then next week on Tuesday, I do anticipate scheduling 2 meetings. One for the lecture component where we will continue to lecture. And like I said, one that will start probably around where lab normally starts, 7:10, 7:15, wherever we normally start. And again, I'll open that up. And that'll probably give you an opportunity, again, to ask any type of questions on maybe say assignment B if you have. maybe some things about the calculations involved with the video that hopefully you had an opportunity to watch. And we'll kind of do two meetings next week. Again, we're going to keep them separate, the lecture, the lab. That way, when they're done recording, they'll be separate as well. So you don't have to like sit through the entire lecture one to find the lab part and that type of stuff. So we'll keep them separate. So what that means is normally when we have those two meeting situations, you'll need to, I'll end this meeting and then you would have to log into obviously the one that's labeled lab. And again, a lot of the time I'll just be there. You can just ask questions since we're not physically doing something. If it's something like I feel you needed some type of lecture on, we'll do a little bit of lecturing about the topic or something like that. So we may do some lecturing during lab time live. And again, if you can't make it or can't do it, all these things should hopefully be recorded and posted upwards so you can watch it up on Canvas. Any questions on anything regarding the class or any of those type of things? Yeah, so there's a question about the homework. You're still going to be expected to do the homework, obviously, and it will be the same situation that will be due on exam day. So whatever day we take the exam, that's when you'll need to turn those in, and obviously it will probably be done the same way. You'll have to kind of upload them as a file on Canvas. And you should still, for your own good, be working through those problems. So if you have questions, I anticipate there will be times when I'm in the lab meeting that there may not be a lot going on. So again, that would be good times to ask questions or get help on some stuff if you need. Other questions about the class or how we're going to proceed from this point on? And again, like I said, I'm going to try over the next few days to sort of get all that stuff up online in terms of grades for the exams and all that kind of stuff. All right, any other questions on anything? All right, well, hopefully it wasn't too painful here, the first one. And again, you'll be able to hopefully see everything. And a reminder that, again, it does take a little bit of time to process the videos and get them up there. But hopefully within a day or so, they should hopefully be up there for you to find. And again, pretty much everything for our class can be found in the module section on Canvas. So make sure that you also continue to check Canvas in terms of announcements and again those emails that are associated with it because things change very quickly as we all found out. All right, if you're all good, I'm good for today, I think. And again, if you have questions throughout anytime, you could always email me at my normal email address and I'll get back to you. Other than that, have a good night, everybody. Yeah, we'll stop this meeting and have a good weekend. It sounds like the rain maybe stopped, so that'd be good. All right, have a good night. Thank you. You too. All right, have a good night, everybody.